In this part 3 of the training for Open Tunnel Designer, we will see how to use TBM cross-sections. So let's start a new file by importing the ground as we did in the previous steps. So we are used to it. Just copy the different layers inside and display the terrain. We will then create a new horizontal alignment using complex by API and mainly placing a long line across the terrain. Because of the shape of the terrain, we cannot put a lot of angles. So starting from one side and getting to the other side, the parameters for the curves doesn't matter as we don't put any. Put the second PI, reset to store the alignment, then select the alignment and open a profile window in the window 2. Then we will cut with the existing terrain to know exactly where we are. So this will take a while as we cross a lot of triangles. And will be displayed as the usual exaggeration ratio of 10. So we will adjust that to have a better view of the terrain. Okay, this is the terrain and we see the different layers. So we will set up the exaggeration ratio to 2 and open the full window, fit the view around the terrain. And now we can place vertical alignment. So we use the same parameters that we used before, so complex by API, using a curve length of 120 meters. So we will start a little away from the terrain. It's already a 12% slope, so that's very big. But anyway, just to put it approximately in the middle, because the cross-section of the tunnel is quite big, and getting out here. Then we select the vertical alignment and we make this vertical alignment active so that we'll draw in our 3D space a 3D alignment that will drive our cross-section. So, seen from the top, if we move a little, we see this 3D alignment, this existing 3D alignment. So we will then place the beginning and the end of the tunnel by placing a reference line. So first, add a tunnel corridor. Don't forget to switch the tunnel unit type to TBM and eventually change the name of the corridor. Then assign it to the horizontal alignment. If you are in top window, anyway, it will search for your vertical alignment. Then we will place the reference line indicating the beginning and the end of the tunnel. So the easiest way is to place it at a given station, make it perpendicular and enough large to see it. Here it looks a little skewed just because we are not exactly on the top window. So once this is defined, we will be able to place the tunnel. But first, to place the tunnel, what we have to do is to import the same from the catalog, the tunnel. So we have seen how we create it, my TBM. So I will import this into the file. So I'm detaching it from the library. I can eventually change the values here. I will use them like that. And here is the same. The segments are defined. Be careful if you change the values that the segments are defined by a region. And if you change too much the size, today as the region are not okay with the parametric, you may lose the definition of the different segments. So we can place the tunnel, choose my TBM as a cross section, and just point to the first reference line, then to the second reference line, and ask for placing the tunnel. This may take more than what you see on the video, as I cut a part of it, because imagine that there is a lot of work to do. The tunnel is quite long and it creates many different segments. And for each segment, you have the different path and turn and so on. So that's a lot of graphics that are imported into the file. So here we can see the tunnel, and if we zoom in, we can perfectly see the segments and the arrangement that we have set up when we define the TBM. So the next step is to create a portal. So for the portal, I have defined a usual parametric so constraint graphic, simply defining the cross-section of my portal, so I can use it in different dimensions, especially to have different shape from the beginning and the edge, and have these different variables. In this version here that I have, just to create the training, the software didn't support parametric portal. So what I will do, I will create, in fact, two different parametric two portal, the first one and the second one with different dimension. Then I will suppress the variable and the dimension, so I can use them into OTD. This should work in the release version. The problem is mainly that we have created this training on non-released version, and we had some problem with some parts of the software. So here it's simple. I create two TBM1 and TBM2, where I will change some values for the first one and the second one. So increasing the particular width, the height, changing the opening width, to take into account the size of the TBM cross-section that I have. Okay, then I enter the file to edit it, check that it is okay, and I will remove the constraint and remove the variable. So just select all the elements and remove the constraint, so they all appears, and I remove them. And do the same for the variables. So they are not used, and I can delete them all. Then store this portal. So save changes. I don't need to redefine the portal extruders because it's already set. Okay, save changes, and I can see my portal. I can do the same for TBM2 by changing the different parameters. It doesn't want to take the different change. Okay. I think there were some problems in my sections. Anyway, we will arrange this by directly edit the file into the DGN. Yes, and when I edit it, so I see that something went wrong. So I will just modify it manually, put the exterior outside. So modify the element. So remove the constraint first and modify it manually. Okay, put it outside on this side and put that side on the other side. Okay. Make it a little higher. And finally, I will be able to save it. So the idea is to have two different cross sections. I forgot to remove the variable, but that doesn't mean anything anyway. Okay. Yeah. Remove these variables and save changes. Okay. So now I can directly import this TBM cross section because I didn't succeed when they had parametrics. So I import these two portal cross section. Then I define a new reference line to define the beginning of the portal and using the one existing for the end of the portal. So I define one portal, the largest one, as beginning of the opening, and define the second one with TBM1, which is smaller, and it creates a 3D element representing my portal. Okay, creating a solid from the first one to the second one. I will put okay, a different shadow mode where we can see this. Okay, then in the next step, we will be able to place rooms and shaft. So first I create the profile. So here also in the version that I used, you will see that when I ask to update my profile, okay, we will see that the terrain has not been removed at the place where the tunnel is. But this has been fixed, and you will see by at the end that it's working correctly. Anyway, we will see. In fact, it's the problem that I made is I ask for profile and not update profile. So we have both profile display. Doesn't matter. We will see. It's just to find out what is the elevation where we should put our room. Okay, and we will adjust it. Okay, so now that we have seen approximately the level of the room, so we can go back to a 3D model and so let's define the parameter for the room. So for the room, we have only catalogs. They are not stored inside the file because it's a very simple. In fact, it's not really a template. It's just three different parameters that we give, the height, the length, and the width. So let's enter the height. That will be 7 meters. The length, that will be 25 meters. And the width which is 12 meters. Now we can place this room onto the tunnel, so we can use it directly. Let's place now the room. So before to place the room, what we will do, we will undisplay the terrain to see better what's happening. So to undisplay the terrain, we just go in the Explorer. Okay, we can do it by levels, or we can go simplest way to go to the Explorer. So in the top, let's display Explorer, and in the Explorer, we will say that we undisplay the soil. Okay, now we can place a reference line where we will place the room. So we place it, adjust the station, and place this reference line. We can now call the place room. We choose our room TBM. Okay, and we will set up a reference elevation of minus 22 meters. That's what we have seen on the profile approximately. Let's give an horizontal offset 9 meters. Surely not enough, but we will see what it does. Okay, and we can see that the room is placed, and yes, the offset is not enough. So let's change the offset. That's quite easy. We just select, because it's already placed. So we just have to select the room by itself. Okay, and see the info. And we can change this. So instead of 9, we can place 25, which is better, because we have to take into account the radius of the TBM. And now it's placed, so we can see it in different way. Okay, and we can eventually adjust it like that in different view. Okay, like that it will stick to the tunnel. So you see, place a room is very easy. It says today there is no interaction between the tunnel and the room, so there is no construction of intersection. The shaft is the same. We don't have any template inside the file. We directly use from the catalog. To create a shaft, a template of shaft, it's very easy because it's also parametric. So let's give the name of the shaft, and we describe piece by piece the shaft. So let's add one, and we go from the top to the bottom. So be careful what we do, it's not always easy. And we have mainly 3 different parameters, which are the external diameter, the thickness of the wall, and the length of the shaft. So here we will change to different things. Okay. So as we start from the top, we will change what we have done here, so you can come back. It's easier when you have the drawing. And so here we will place of the upper ring. Okay, so here, 2, 5. Okay, so we have the interior of the shaft, which is at the same level, but the exteriors, we have a change. So now, in the same way, we can place the shaft. So we will use the same reference line because we will put the shaft on top of the room, for instance. Okay, choose -18, add the reference line. Okay, so we see we put it too low. So in the same way, we can change the elevation of the bottom. So let's put it higher. So a quick calculation before placing it would have placed it at the proper level. Okay, and we have now the shaft going from the room, and we can continue our top ring. So here you see it from the top view. And while we have in the top view, now we will see some drawing generation that we can use. So it's a civil drawing, so that will help you to define horizontal drawing, plan drawing. So this is the same tool as in the civil. That means that you define your drawing characteristic. What is the scale? We are using an A1 plan, and we define the beginning, and automatically it will adjust the different pages to cover the whole drawing. Maybe we can create an overlap. So let's change it and put 20-meter overlap. So now it reappears with the overlap. Perfect. And because we say create drawing and show dialog, it will ask, so what is the mode that we are asking? It's plan. We use the A1 plan drawing seed. We define the size for the annotation and the size for the drawing itself. And it will automatically cut the different drawing sheets and display them in two different ways. So the sheets that reference a saved view from from the tunnel. And here we can see, for instance, the tunnel with the room and the shaft. In the same way, we can have it for the profile. So this is with an updated version. So, and you will see that in that case, the ground has been, the intersection between the ground and the tunnel has been updated. So if I go to my profile view, okay, this is my profile view. And if I ask to update it, this one, so now we see that the interior has been removed. So this is really an intersection with the terrain, and all has been done. So what we can do is change the exaggeration ratio. before we wait for everything to be done in the intersection. Sometimes it takes a little longer than what we expect. Okay. I think it's done, yes. So let's change the exaggeration ratio to 1. Okay. And now we can place the corresponding profile drawing pages according to the one we have set in horizontal. So let's place a boundary, but this time for profile. We will use an A1 profile, so we display only the profile. We can also display both profile and plan view on the same, and we say the method is from plan group. There is not the terrain everywhere, so we use the active vertical to define where we put the level at which we put the views. So it will center the active vertical in the middle of the sheet. We will set back the exaggeration ratio, vertical exaggeration ratio to 1. That will give much more space. Okay, 8 on the drawing. And now we can place it. So it just prompts for identify profile view. And automatically you see that he placed the different sheets according to what we have on the plan here. Profile, okay, good. So we have already the plan, so we don't need to change to update the plan, or we could generate both at the same time. Yes, we want only profile. Okay. And now we can say OK. And in the same way, it creates the different sheets and calling back as a reference the different part of the model that are cutted. Okay, and we have the different drawings. And that's all for that training.